Hi everybody, we are going to be watching a couple of videos to learn Standard 9. Before we do that, we need to review a few terms from Standard 1, the first one being angle bisector. If you remember, angle bisector cuts an angle into two congruent angles. So here we have angle ARE, and I'm trying to hold this camera, so excuse me if it's a little shaky. So I have angle ARE. Okay, and it says ray RB bisects angle ARE. So ray RB bisects the angle, bisects that whole angle. So it cuts the whole angle into two congruent angles, two equal parts. So now we have angle ARB is congruent to angle BRE. Now as we go through these, feel free to pause the video and take down some notes. We want to make sure that you get all of these down and really understand them, because the rest of S9 isn't going to make a whole lot of sense if we don't have these basic terms down. So our next one here is midpoint. Okay, midpoint is the middle point on a line segment. It cuts a segment in half and creates two congruent segments. So I start out with segment LR. Okay, I start out with that whole segment, LR. And this M, that's my midpoint. Okay, point M is my midpoint. That means it cuts LR into two equal segments. Remember, these tick marks is how we show we have two equal segments. So now LM is congruent to segment MR. Next, I have vertical angles. Okay, the angles across from each other, as you can see on this picture on the bottom left, those are vertical angles. Vertical angles are always congruent to each other. So here we have angles 1 and 2. Those are vertical angles. Those are congruent to each other. Now these, the top and the bottom angle, I haven't named those, but those are also vertical angles. They're also right across from each other. We have to make this perfect X if we're going to look at vertical angles. Okay, so these two are also vertical angles. So those are also congruent to each other. Next I have the reflexive property. The reflexive property just says that if a segment or an angle is equal to itself, so we have our triangle on the left here. Well, we have two triangles, triangle ADB and triangle ACB. So looking over here, I have this triangle and then this triangle. These two triangles, they share AB. They share segment AB. So I can mark it congruent to itself. Sometimes it's easier if we pull the triangles apart. Then we can see that the triangle shares AB with the other triangle. Okay, so we have these two triangles. I started out with these two. Split them apart so that I have them redrawn here. And I see that AB is the same on both of them. This helps us as we try to prove triangles congruent using our congruent shortcut. So that gives us the one set of congruent sides that we may need for using our congruent triangle shortcuts. Next I have perpendicular. Remember that upside down T? Okay, our upside down T, that is the shorthand way of writing perpendicular. Perpendicular lines, they create right angles. Okay, now they don't just have to be lines, they can be segments or rays as well as lines. So over here on our left, it says AB, segment AB, is perpendicular to CD. And I should change that. This should be line CD. Okay, we see in the picture that's line CD. Alright, so we know those two are perpendicular to each other. So we can say that angle AED is a right angle. Okay, angle AED. That's a right angle, or 90 degrees as we write right here. Angle AEC, that's also a right angle, 90 degrees. Angle DEB, 90 degrees. And CEB, also 90 degrees. Alright, then finally we have CPCTC. Now this one is a new one. It stands for corresponding parts of congruent triangles are congruent. So this just means we have proven two triangles are congruent using one of our triangle shortcuts. By using one of our triangle shortcuts, we've already said that we have 3 pieces congruent. But if triangles are congruent, then each piece has a matching piece in the other triangle. Okay, so if we go back up here to this one, if I had proven these 2 are congruent using hypotenuse leg, for example, then I would also know that these angles up here at the top, those are congruent. So once I prove the 2 triangles are congruent, then I can say the other pieces in the triangles are congruent. And we'll see a little bit more of that in our examples. Okay, make sure you have all these definitions written down before we move on. Okay, so we've gone through the vocab. Now let's get back to our examples. Whenever we do 2-column proofs, we start by writing our 2 columns, statements and reasons. And we look at our givens. We look at what we're trying to prove. So first, we're given JK is congruent to ML. So JK is here, ML is here. I went ahead and separated my triangles. Sometimes it's hard to visualize when they're lying on top of each other like that. So I drew it over here, JK and ML congruent to each other. Then I'm also given angle JKL is congruent to angle MLK. All I'm trying to do is prove that the 2 triangles are congruent to each other. So, as always, I start with my givens. So given number 1, segment JK is congruent to segment ML. My reason? Given. It's already marked in the picture for us, and I already marked it in our new picture as well. Next, angle JKL is congruent to angle MLK. Reason again is given. So JKL, or here JKL, is congruent to angle MLK. MLK. Which you see already marked in the picture given to us, and I already marked it in our new pictures. Lastly, I gotta look for another piece that'll prove these 2 triangles are congruent to each other. So if I already see side angle on each triangle, now let's see if there's anything else I can gather from my picture that allows me to use some triangle shortcut to prove these 2 triangles are congruent to each other. Well, of course, I see that KL is on both triangles. So I can mark those congruent to each other, or to itself, really. And I write that out. Segment KL is congruent to segment KL. Okay, this is called the reflexive property, or if you want to write out what reflexive property means, segments are congruent to themselves. I see that from the picture. So remember, in parentheses we write where we got the information from our picture. So now I have side, angle, side on both triangles. That's enough to say that triangle JKL is congruent to triangle MLK. So JKL, that triangle, is congruent to triangle MLK, that triangle right there. So that's my final statement and reason. So side angle side, we already said side angle side, side angle side. 1, 2, 3. So my first side came from here. Then my angles came from step 2 and statement 3. That's where I got my last side. So statement 1, side, statement 2, angle, statement 3, side. So side, angle, side came from statements 1, 2, and 3. Let's move on to our second example. Gonna have to move this a little bit. Okay, let's see if I can't zoom in for you a little bit better here. Okay, that could work. So 2-column proof, statements and reasons. This one, it doesn't say everything you're given, but you see it in the picture. So we'll just write out what we're given from our picture. We are trying to prove that ST is congruent to VT out here. If we prove the 2 triangles are congruent to each other, then that's enough information to say these sides are also congruent to each other. So first, let's write out our givens. So my first given, SU, is congruent to UV. I see that from my picture. So statement SU is congruent to UV. My reason is given, and that information is from my picture. The next thing I see in my picture is that angle TUS is located here, is congruent to angle TUV, located right here. Those two, they're both 90 degrees, but that also means they're congruent to each other. So I went straight to the two angles are congruent to each other. That's a given from the picture. My statement number 3, I'll have to gather some information. There's nothing else given to me right on my picture already marked. But I do see that right now I have a side and an angle. Side and an angle on each triangle. TU is located on both triangles. So I can use reflexive property to say that TU is congruent to itself. Okay, reflexive property. And I'm going to move it over just a little bit. That's from my picture. So TU is congruent to TU. Reflexive property from my picture. If you remember, reflexive property simply means segments are congruent to themselves. Now I have enough information to say I have two congruent triangles here. I have side on each triangle. I have angles on each triangle. Then I have side on each triangle. So side, angle, side. So triangle, TUS, that triangle TUS is congruent to triangle TUV, Remember, order matters when giving congruency statements. So TUS, TUV. So we're going in the same direction each time. TUS is congruent to TUV. That's side, angle, side, like we said, side, angle, side. I got that information from the 3 steps above, my sides, my angles, my sides. Now that I have two triangles that are congruent to each other, I know each piece in each triangle has a matching piece in the other triangle. So U matches U, SU matches UV, TU matches TU. We also know that this angle V matches this angle S. We know that right here, this angle matches this angle right here. We know that TV, that segment, matches ST. So ST is congruent to VT. That's our next statement. It's our final statement. I'll move this over for you. All pieces in one of the triangles that are congruent have a matching and congruent piece in the other congruent triangle. That's CPCTC. Corresponding parts of congruent triangles are congruent. So corresponding parts just means the pieces that are matching in each triangle. So corresponding parts here would be this angle and this angle. For example, so corresponding parts in congruent triangles, we already said these two triangles are congruent to each other. Incongruent triangles are congruent. So that means those two angles that are corresponding, those are congruent to each other. These two segments, ST and TV, that are corresponding in the two congruent triangles, those are congruent to each other. Let's move on to our last example. Okay, I'm given that MN is congruent to MP. MN and MP are congruent. I have some perpendicular line segments here. I'm trying to prove that my angles are congruent to each other. So again, my plan of action, use these givens, prove that the two triangles are congruent to each other. Once I've proven that, then that's enough information to say CPCTC. Corresponding parts of congruent triangles are congruent. So if they're matching triangles, congruent triangles, then I have matching or congruent parts in the triangles. First statement I wrote out is my first given. MN is congruent to MP. MN is congruent to MP. So let's mark that. That's a given. I wrote down my second given, MP. Segment MP is congruent to segment PO. I'm not congruent, perpendicular. MP is perpendicular to PO. So MP is perpendicular to PO. Remember, perpendicular means it creates a right angle. It creates that 90-degree angle right there. That's another given. Sometimes I can do some things with given beside just stating them here, marking them in the picture. I already marked in the picture what perpendicular means, but I need to write it out. So my next statement says that angle MPO, angle MPO, this angle right here, equals 90 degrees. Because that's what perpendicular means. Perpendicular means it creates 90-degree angles. So that those perpendicular segments created this 90-degree angles. That's why I have this 2 right here. The perpendicular segments created the 90-degree angle. I got that from step 2, statement 2. Next, I'm going to write my third given. MN, segment MN is perpendicular to segment NO. MN is perpendicular to NO. What that means is it creates a right angle. So I can say angle MNO equals 90 degrees then. So I got that the same way. I know that perpendicular creates 90-degree angles. A simpler way to put that would be, that's the definition of perpendicular. So I got that information from step 4. Perpendicular means it creates 90-degree angles. So by definition of perpendicular, I now have a 90-degree angle. So it's okay if we shorten things and put definition of perpendicular. If you want to write it out the long way, that's perfectly fine too. Okay, my next statement. Let's think about this. So far, if I'm trying to prove the 2 triangles are congruent, so far all I have is a side and an angle. So I'd have to get another side. Side angle side is okay. I couldn't do side angle. I'm not allowed to do that. But I could do hypotenuse leg. If I have right triangles, I would have to do hypotenuse leg. These here, MN and MP, those are some legs. Those are congruent legs in my 2 right triangles. Hypotenuse would be this segment here, this segment MO. That would be the hypotenuse in both triangles. Hypotenuse means the side that's across from the right angle. So MO would be my hypotenuse in both of them. MO is on both triangles, so I can use reflexive property to say that the 2 are congruent to each other. Reflexive property, remember, means segments are congruent to themselves. MO is congruent to segment MO. That's the reflexive property. Segments are congruent to themselves. I see that in my picture that I can use reflexive property. Now, I have enough information to say the 2 triangles are congruent. Oh, not yet. One step I forgot. I don't have enough information yet. All I've said about angle MPO and angle MNO is that they both equal 90 degrees. We actually have to write out a step saying that they're congruent to each other. So angle MPO is congruent to angle MNO. If they both equal 90 degrees, they have the same measure, then of course they're going to be congruent to each other. So if they have the same measure, they're congruent to each other. And I have to actually write out that step. It seems very intuitive, just like a lot of this does, but we have to write out every single step. Okay, I can't see this. There we go. 3 and 5 is where I got that information. So 3 and 5, I put those together to get 7. Now I have enough information to say hypotenuse leg is how I prove these 2 triangles are congruent. Triangle MPO is congruent to triangle MNO. Okay. Hypotenuse leg, remember I have to have the right angles for hypotenuse leg. I have my congruent legs here, and then my hypotenuse is MO. So hypotenuse leg, I used 7, I used the right angles. 6, I have my hypotenuse, and 1 is where I got my congruent legs. Now, all I have to do is use CPCTC to say that angle NOM, so this angle right here, is congruent to angle POM, so this angle right here. Because my two triangles are congruent, they have corresponding or matching parts in the triangles. These two angles match each other. They're corresponding angles in the two triangles, so they're congruent to each other. And I got that information from step 8. So step 8 said the two triangles are congruent, so of course they have matching parts in the two triangles. Okay, and we're done with this video. Make sure you got it all written down. Go back and review it if you need to. Press pause. Make sure that we are taking notes well.